Calculus, a word often used to denote a problem of extreme difficulty or complexity. And to be in a calculus class at any grade means you are better than 99% of the population at mathematics. But how hard is calculus really? Well, to ask how hard calculus is, we first have to break down what it is. First of all, I want you to think of everything before calculus as being a stationary snapshot of where the baseball is in the air. Whereas calculus tells you the total motion of the ball across its entire movement, as well as telling you the future movement of the ball as well. Beyond that, calculus relies very heavily on the concept of infinitely large and infinitely small numbers, two ideas that are polar opposites of each other, yet they're very similar because infinitely large and infinitely small numbers involve the concept of growing in size forever, aka to infinity, or shrinking in size indefinitely, aka infinitesimally small, also known as an infinitesimal. And therefore, they aren't a number in the conventional sense of the word, like the very small numbers 0.001 or the very large number 100 billion. Since even though those numbers are really small and really big, the sense of infinity implies not that it's a very big number, but that it's always getting larger and it has never ceasing growth. Despite these infinitesimals and infinities being intangible, like normal numbers, calculus gives us a, albeit unfamiliar, way to calculate values at these extremes by, instead of plugging in numbers like in algebra, we cancel out variables. This new way of thinking does often present a decent learning curve for incoming students who have never dealt with equations in this way before. In my professional experience, I'd probably give it a 4 out of 10 in difficulty. Just like putting a plus sign between two numbers gives you the sum, or a division sign between two numbers gives you the quotient, as to just sticking this fancy looking tall S shape called the integral in front of a line give you the area underneath the line. As you may have guessed, adding up the area for straight lines doesn't need to use fancy calculus techniques, since these lines form either rectangles or triangles, both of which have simple enough formulas for calculating their area. In the case of a straight vertical line, the area underneath is 0. However, in the case of the curved line like this, we need to return back to that idea of infinitesimals, the infinitely small numbers. To measure a curved line, we can add these rectangles starting with a few large rectangles. We get an easy to calculate number, but it's not very accurate because there are gaps, and therefore, we're not getting the total area under the line. We can shrink these rectangles further and add them up. We get a more accurate idea of what the area is. Eventually, we shrink the width of these rectangles so much it quite literally fills the entire area under the line. We do this by making them infinitely thin. Well, infinitely thin effectively means 0. So how can we add them up and not get 0? Since 0 added to itself, no matter how many times, in this case infinitely many times, is 0, right? It is. But you see, unlike in pure math such as algebra, it doesn't matter how zoomed into two neighboring points you get. There will always be an infinite amount of points in between them. However, calculus, on the other hand, kind of just says, let's pretend that those infinitely small points are just really small, but ultimately there's a minimum size. And because now we are effectively treating them as just thin rectangles, we can just add them up. In order to not have to add them up manually, not that it would work anyway, since you don't even know their thickness, it's so thin, we use the integral. The rest of high school calculus is just doing this with varying degrees of complexity. At first they begin very easy, but they definitely do increase in difficulty, and some are unsolvable with conventional means. Overall, I'd give it a 7.5 out of 10 in difficulty, since some of the problems do require an additional layer of abstract thinking, and may require some steps that you don't necessarily learn, but you have to do in order to get to those in order to get to where you can start using the steps that you already know. So high school calculus gets an overall score of 5.75 out of 10. This means it's not too hard, but has some tougher elements. I find that some parts are very easy for students, but there are a few parts, such as the real-world application problems, that a lot of students do struggle with. Many of my friends did pass this class with a 90% or greater with moderate difficulty, so it can definitely be passed with a C in the class with very little effort put in. Despite this, I think the reputation of calculus being such a big deal is deserved, as it plays the role of baby's first real math class. Everybody who takes this class remembers it fondly, since they either think of it as when math used to be easy, which is how I used to think of it, but not too easy, where it was still a little bit of fun from the challenge. If they're not going to keep going into higher math levels after calculus, I think it does play a good role as a natural stopping point to cap off their involvement in math, and they get to see a little taste of what math actually becomes later on. Thanks for watching.